Every morning, admissions teams log into their CRMs and face a massive, static pool of applicants. Counselors are forced to manually sift through thousands of records, trying to figure out which applications are moving forward and which ones have stalled out. The modern solution to this bottleneck is deploying predictive AI to read the funnel. An automated system can analyze behavioral signals overnight to predict student yield and flag likely enrollment melt before the student actually walks away. But standard AI tools introduce a critical security flaw. To get those predictions, institutions usually have to paste raw student rosters directly into external prompting environments. Vendors try to solve this with policy promises. They write terms of service agreements that pinky swear they won't train their models on your extracted data. A legal shield does not eliminate the institutional liability of physically exporting specific, personally identifiable information, names, email addresses, physical addresses, and social security numbers, into third-party language models. True FERPA alignment for AI cannot rely on a policy promise. It requires a strict structural guarantee. This is the exact principle behind CeliaConnect. It is an AI assistant built exclusively for institutions running Slate, designed entirely on architectural isolation. It operates as a closed-loop data pipeline. The system reads the records and produces insights every single day, without any data ever breaking your tenant boundary. Implementing high-efficacy predictive analytics in higher education requires physically blocking PII exposure at the database level, preventing the AI from ever seeing personal identifiers in the first place. This zero-PI pipeline begins with a daily outbound extraction run through the Slate query service. Personally identifiable data types, student names, physical addresses, SSNs, and essay text hit a hard structural firewall. They are trapped inside the institution's boundary. What actually crosses the edge is a filtered stream of abstracted, anonymous ID codes and numerical timestamps. These are purely behavioral signals. The pipeline automatically extracts application stage transitions, milestone completeness flags, and specific engagement timestamps. To make sense of these isolated numbers, the system maps the signals against the institution's localized per-org data dictionary. Generic AI models often invent opaque, standardized field codes to guess at a student's intent. Because this system reads your specific data dictionary, it reasons based entirely on your unique institutional baselines. This query process executes as a single, scheduled overnight batch. By mathematically excluding personal identifiers from the outbound query, the architecture neutralizes data privacy risks before the AI ever begins its analysis. Once the batch of anonymized IDs and timestamps clears the firewall, it reaches the isolated AI reasoning engine. The central node processes anonymous data packets, routing the signals into parallel channels to calculate 3 distinct analyses for every student. The first vector is engagement, determining if a student is actively paying attention. Raw activity signals, like portal logins and email opens, aggregate into an explicit score from 0 to 100. The second vector is readiness, measuring if the application file is moving forward. It calculates stalled days, flags missing documents, and compares timelines against baselines for a second 0 to 100 score. The third vector is yield, measuring the actual probability an admitted student will enroll. It factors in baseline probabilities and financial aid timing, outputting a strict metric between 0 and 1. Finally, the engine synthesizes these 3 vectors into a master risk tier, low, medium, high, or critical, and generates a single recommended next action for the counselor. Highly accurate predictive analytics do not require a student's identity. They require clean, contextualized behavioral data calibrated to institutional baselines. The final phase of this overnight pipeline is the inbound write-back process, returning the calculated insights to Slate. As the diagram shows, the 3 vector scores, the risk tier, and the counselor recommendation are consolidated into a single structured JSON payload block bound to that original anonymous ID. Outputting structured JSON eliminates external dashboards. The block crosses back over the institution's boundary. Using the anonymous ID as a key, it locks directly into a matching slot in the native database schematic. This payload systematically populates dedicated custom fields on the student record, formatting the incoming data as structured elements your team can immediately query. This step automatically creates a tamper-evident audit trail. Every single write-back generates a verifiable before and after record in your system. Throughout this entire round trip, from extraction to reasoning to write back, the pipeline has not processed a single name or email address. Designing this predictive system as a closed-loop pipeline completely prevents workflow fragmentation. The single source of truth remains entirely within your CRM. For an admissions counselor logging in the next morning, the complex back-end data architecture is entirely invisible. This mock interface shows a standard Slate student record exactly as a counselor sees it. The overnight analysis is right there, populating custom fields for engagement, readiness, and yield, alongside a recommended next action. Because the data lands natively in the records they already use, there is no new software interface for the admissions team to learn or adopt. The morning routine shifts. Counselors filter the yield field to instantly triage their pool, identifying high-risk or stalled applications before making their first call. For enrollment vice presidents, this provides a daily aggregate yield probability, enabling accurate 60-day funnel forecasting based on real-time behavior. That aggregate forecast directly feeds into precise melt cost calculations, giving leadership board-ready financial reporting well ahead of census day. And crucially for your IT and security teams, this architecture secures per-tenant database isolation, combined with verifiable zero PII structural constraints. CeliaConnect proves institutions do not have to choose between advanced predictive analytics and rigorous data privacy. When the architecture is correct, you can guarantee both.